Johanna.
All right. Before our guests introduce themselves to you, here are some rules for our audience, for the students. Please keep yourself muted at all times. And then if you want to ask a question, you could ask your question by typing in the chat box. And once you have a question typed, please wait to be called on to unmute yourself and ask your question, or I could always ask the question for you. Last time that we had a panel, I asked for questions from you guys, and I am going to ask some of those questions today. So, a lot of the questions, or I'll say most of the questions that we have today actually came from you, from students, okay? And then I encourage students to turn on their cameras for our speakers. It'll be great for them to see your faces. Okay, so once more, welcome. This is our second career panel for the year, and there will be more to come. For today, we are graced by 4 professionals coming from Lawrence Livermore National Lab, Martinez Refining Company, and we have a familiar face coming back again, volunteering for the second time from PG&E. So can we have our guests introduce themselves? Let's start off with Noah, and then Johanna, then Kenneth, and then Joshua.
So can y'all hear me okay?
Yep.
Great. So my name is Noah Allen. I'm a postdoctoral researcher at Lawrence Livermore National Lab. I graduated from Virginia Tech last year, and I'm doing research over here in Livermore. I work on gallium nitride, which is a semiconductor, and I do a lot of clean room research here at the lab.
Thank you.
Okay.
Hi, I'm Johanna Schwartz.
Okay.
I'm a what?
No.
Hi, I'm Johanna Schwartz. I'm a postdoctoral researcher at Lawrence Livermore National Lab. I'm actually a polymer chemist. I work a lot with additive manufacturing and creating new materials and chemistries for those processes. I graduated from University of Wisconsin-Madison, and yeah, I've done a lot of traveling for school and everything, so feel free to ask about that.
Thank you very much, and welcome. Kenneth? Ken?
Hi, I'm Kenneth Forward. I work for PG&E. I currently am part of our SALT task force, which is Strategic Allies Leading Transparency. But in my time at PG&E, I've worked at the nuclear power plant, gas and electric, supervised crews, and worked in the IT organization, building custom mobile applications, doing data analytics. And in the last 18 months, supervised the team that does all the wildfire safety inspections. Thanks for having me.
Thank you. And then let's go on with Joshua.
Well, good morning, class. My name is Joshua Wells. I work for the Martinez Refining Company, formerly known as Shell Oil Martinez. I graduated from Cal State University, East Bay, Hayward. I'm local, born and raised. Was a welder once upon a time, but now I'm basically what they call a maintenance team leader. So I'm in charge of maintenance and projects here at the refinery, and work closely with a lot of trade industry.
Thank you, Joshua. So as you guys can see, we have an array of careers being featured today. We have a researcher from Lawrence Livermore National Lab, a polymer chemist, and then we have an engineer from PG&E, and then we have a maintenance team leader who used to be a welder. Okay, so let's get started and ask the first question for our guests. The first question comes from Alejandra Cuevas from my 4th period class. Have you always been interested in engineering, or was it something you suddenly became interested in? So let me just repeat it. Have you always been interested in engineering, or was it something you suddenly became interested in? Oh, I'm sorry, not just engineering. have you been always interested in the field that you worked in, or was it something that you became interested in? So let's start with Johanna this time.
Hi. So I always knew science, and so I always knew that that's what I wanted to do, but I wasn't quite sure which field of science, particularly in high school. I tried everything else. So I took bio classes, I took chemistry, I took engineering. And I think it was in college that I, decided that chemistry was the one that I enjoyed because I liked making complex things from, you know, generally simple molecules. And so that's why I really liked it. And that's kind of how I ended up here now. I just kind of followed that path.
All right. Thank you. Thank you. Let's hear from Joshua.
So I started out just basically doing labor work is kind of how I got into the welding and industrial maintenance industry. I was going to school at night and I was working during the day to pay for it. And I think
Good
the
for
industry
you.
kind of took over and, I got into welding. I had my own welding rig for many years and then got into the refining industry. But I actually went back and finished college after the fact. So for me, it was kind of got interested in it because of the company that I worked for had welders, and I kind of piqued interest in it once I learned what it was, and I kind of went down that path, and kind of stepped away from college for a few years. So it's kind of a different, transition for me.
Wow, that's a great path to take. So you stopped school, you started working, and then went back to school after.
Correct. Yep.
So there you go, kids. So just to let you know, there's more than one way to get into the career that you like. Okay. How about we hear from Ken?
Sure. So actually, similar to Joshua, I started and then stopped and then went back to school. But I've always liked power. I was always interested in electricity. So I always knew I wanted to do something around and with electricity and electronics. My two passions were always like power, electricity, and cars. So I was fortunate enough to do a little bit in both. But in high school and before college, I grew up doing general construction with my dad and my grandfather. So that laid foundation for like working with my hands, working with tools, figuring out how to build and do stuff. And then when I was able to go to college, I started studying electrical engineering, which led me into power in the utility industry.
Awesome. Thanks for sharing. All right. Noah?
Yeah, so I'm an electrical engineer. I forgot to mention that before, but as a kid, it was like I always wanted to break open like remote controls and like understand like how they worked. RC cars, computers. I ended up like building when I was a kid, and I just wanted to learn more and more about it. And so I decided to major in electrical engineering, and just ever since then I've wanted to know more and more and more. And then research was kind of like the path that that I was, pushed into just because I wanted to learn more and more. So I ended up becoming a researcher and just, going to college. I did my bachelor's and then my master's and then my PhD. I just went straight through because I enjoyed it so much.
Thank you. Does that mean that now that you're a researcher, you don't use any of that thing that you learned on electrical engineering, or do you still apply it?
Oh yeah, yeah. So so there are a couple of paths once you graduate, and I hear a lot of people talk about after they graduate from undergrad, they don't really use anything from their undergrad. But I kind of made it a point to only look for a career path that would like allow me to use every piece of what I've learned. So I like almost daily I'm using everything I learned all the way up from high school. Just today I was trying to solve a problem where I was trying to figure out like if a point lies inside of a triangle, just using the 3 points on the triangle. So I mean every day there's always something that I'm recalling from the past.
Awesome. Thank you. And Noah mentioned about the things that he did as a kid and how that helped out with who he is right now. I have a follow-up question to our other guests. This is from Nancy Garcia Hinojosa, who is a student here in first period. Her question is, what hobbies did you have when you were younger that are similar to what you do now? Since Noah mentioned about what he did when he was a kid. This is open to anyone. So again, what hobbies did you have when you were younger that are similar to what you do now?
I guess I can start us off. So I really am into arts and crafts, just in general. Anything I can do with my hands, whether it's building something, whether it's making something. I think the creative process of, you know, having something come to fruition, I use daily. So in additive manufacturing, a lot of times it's an art more than a science, or it is an art and a science. So I use that every day. Duct tape is my best friend. So anything you can do and build really relates downstream, I think, to science and the research process.
I know some of my students can relate to that. My students who are in the robotics team, if you can solve it fast, by duct tape. And
I was in the robotics team. Yeah, I duct tape wins.
and also, I think you pointed out that STEM, science, technology, engineering, and math, is always related to art as well. There's a component of art in there. That's why some prefer to call it STEAM instead of STEM. All right. Anybody else who wants to share any hobbies they had as a teen or as a kid and how it shaped your future?
Yeah, I'll share. So growing up, I used to work on cars with my dad. So getting into welding, I think that was the first time I was exposed to welding and any kind of trade work. We didn't have it at our high school. So, my old beat up pickup truck that I used to have, I think that was the first time I did any kind of welding or working on cars. But my uncle used to build cars for a living, so I did a lot of shop work at the house instead of at school. So that was a big thing that kind of piqued me into, getting interested into metalworking and doing work with my hands.
Great, wonderful. Not just toy cars, but actual cars. Truck. Awesome. Awesome. And I'm pretty sure there are some of our students who are actually doing the same thing. Awesome. All right. So why don't we transition and learn more about your high school background? Because students are always interested to know, okay, how you all did in high school. So students hear from us teachers a lot that you should be good in science or in math if you want to go into STEM. So is that true? What kind of a student were you in high school? How good were you in science and math? And a follow-up question to that also from Nayeli Alvarez from first period is, do you think high school helped you in some way to reach your goals? Or do you think it was mostly you who did all the work to reach where you are today? So again, let's focus on high school, how you were a student. Were you good in science, math? And did high school help you in some way to reach your goals today? Can we start?
Sure, this is Ken. I can start. Yeah, high school, I was a pretty good student. I always liked math and science and all that kind of stuff. And I always say, and this transferred into college, even though I like math and science and things like that, it didn't always like me. So I didn't always perform as well as I would have liked, but I always made sure that I learned something from it. So it really was helpful. And I made sure to make time for the creative things too. So I took a lot of I took physics in high school, I took calculus in high school, and some of the other sciences, especially my senior year where you don't have to take a full load, but I chose to anyway. But I also took like a couple of fun classes too. Like I like to paint, I like philosophy. So I took a couple of those things to kind of balance out all of that technical stuff and all of, those artistic, parts of my mind and fun things too. And I carried that on to college. I actually have a minor in philosophy as well. So high school was definitely fun. it definitely was challenging at different parts, and it did prepare me for college and for what I'm doing now, because some of the things that I started in high school carried me on to college and prepared me so I didn't have to take them in college. And then from there, to some of the things that I do now, like stuff, basic stuff like, the scientific method and the approach to problems. So,
Nice. Thank you for sharing. So Ken made it clear, okay, in his case, that high school prepared him for college and career. Okay, can we have Joshua?
Yeah, I'll touch on mine. My high school experience was a little different. I was really big into sports and a lot less big into school. If I'm being completely honest, I was football, track. I played hockey, all year round. So my junior senior year, I think I kind of started to taper off. My grades started to taper off, and it wasn't until after high school that I realized the importance of that. I would say that paying attention and really focusing on school during high school and after is important. I did terrible in algebra 2, and I remember having to retake that class, and I struggled through it. And in my later years, taking calculus and getting a 98% in the class, it was like a night and day difference. And I think it has to do with your mindset. A lot of it for me, in high school, it just was more about the fun and less about the schooling. And as you get older, one thing that you look back on and realize, at least for me, is wish I would have taken high school a little more seriously and been a little more dedicated at that time. Because when I hit the ground running for college, I worked a lot harder at it, and I did a lot better in college than I did in high school. But my take is it's a key to a doorway, and what doorway you use it for is kind of up to you. With the career and with college, with high school, with all of it, you get out what you put in, and I think that applies to all education. Is you get from it what you put into it. And for me, high school was a little bit rocky for me, but I wish I would have paid more attention and been a better student. But I think and when I got into college, things changed for me a lot different. I did really well as a straight A student in college, and worked a lot harder. And in your career, you'll realize the importance of it as you try to progress in life. That the education is definitely key, especially if you're trying to get into engineering or any type of career field that's going to require it.
Thank you. Well said. Was there just a follow-up question? Was there a particular subject that you wish you did really well in high school that would have helped you in your college? Joshua?
Yeah. Sorry. Math. I think math for me, depends on your course of your school, but I know for engineering especially, it's very math focused, and I know for business also very math focused, and it's important. So to do well in math, I think is key, because the math is always going to be the requirement for the degree, and it's always going to be more and more challenging the further you go. I know once you start getting into calculus and advanced calculus, it's definitely a challenge. So you got to make sure that you try to focus on the math side, and I'm sure people in this group can attest to that, and science as well, depending on what type of career path you want to go in.
Thank you. Thank you very much. Let's ask Noah the same question.
Yeah. So, as far as high school goes, I think having, just like Joshua said, having a solid base in math is pretty key, and not being the best in calculus or your AP math class. Just kind of understanding the basics, being able to like manipulate equations and numbers, and being able to apply it to real life is pretty key to being an engineer. It's something I was just kind of blessed with whenever I started high school. But as far as science and all the other classes, I wasn't great unless I could really like understand how it applied to like my everyday life. So physics was hard for me. Chemistry was very hard for me. Biology was even harder for me. But I ended up going into electrical engineering, which was much more math based and then physics based. So having those is understanding those is pretty key to my career. But the thing that I actually found most helpful when I was in high school actually came from my mom. She realized that because I came from a really small high school, I was in Virginia and I had like a class of 30 students, that there weren't a lot of opportunities to really like stretch my legs. So enrolling me, because you know we were lucky to have the means to in engineering camps, just so I could try it out and see if that's really like what I liked. I wanted to be a computer science major for a long time, and then doing it for like 2 weeks at a camp made me realize I did not want to do that at all. That was like the key thing that really helped me decide what I wanted to do. I knew I liked electronics, but I didn't really know I liked electronics until I tried, you know, robotics and computer science. So classes even like this, like what you all are doing right now, is great to help you understand, you know, what you want to do in your college career.
Thank you, Noah. And we also believe that that's why we are starting this early with career panels and career mentoring. And most of our kids here are freshmen, but we do have some upperclassmen who are in a way a bit lost. They don't know what they want to do. And so we're hoping that this type of sessions will help them. So Johanna, how about you share with us?
Yeah, I grew up in Las Vegas, Nevada, and at the time for my high school, Nevada was 49th in education. So high school for me, I actually joined they had magnet programs. I was in the International Baccalaureate magnet program, and that made it a lot better having those programs. So programs like this, I think, are pretty amazing. But high school as an institution wasn't really that hard, just because it was mostly at the time teaching for exams. So I think for me, the things that made, you know, high school useful were teachers, finding, you know, particular teachers that I really enjoyed as mentors and helping me in, you know, figuring out what I wanted to do. And then after school programs and clubs. So I really used that to try every type of science that I wanted to try. So robotics, I did after school research at UNLV, in hydrogen fuel cell polymers. That was really cool. I did a science fair project. I took some like bio random projects. I just really tried after school to have all of these clubs and do things that I thought that were things that I wanted. And I think that really helped. But school itself was just an ends to a means, at least for me, you know, to get to college, to try everything else out for fun, and then figure it out.
Thank you. And I'm so glad to hear you mentioned the word mentor. So once you find that teacher, how were you able to, in a way, recruit that teacher to mentor you, to help you? Can you tell us what you did?
Yeah, absolutely. For me, a lot of the teachers that I really admired were teachers that had after school programs that were, you know, committed to being there for people. And so it was really kind of easy to make that connection. I could join their club and then we, exchange books. I read after school a bunch of concepts. And so it just opened up conversation. And I felt like every teacher I talked to was open to that type of relationship. It was really nice, I think, in my school.
Thank you. Thank you. Now, since you mentioned that, let me plug that we have a robotics team, and then we have the girls only career mentoring. So robotics team is open to everyone in this class, and the girls only mentoring is open to the girls. So these are all after school activities that you guys can take advantage of. You get mentored by your teacher, but more importantly, you get mentored by actual professionals. Okay. So thank you for pointing that out, Joanna. So let's move on. All right. So here's a question for all of you again. Okay. So what should students do now in high school to better prepare them for college and career? Any tips and tricks that you can share? More like of the study skills mindset. What should they do in order to prepare themselves for college and career or career? Something that you wish you knew when you were in high school.
I'll touch on this one first. if I could give any kind of advice to the high school students, it would be to do your homework on the career options that are out there, right? I was kind of clueless coming into the working world, to be honest, as far as what I wanted to do or even what direction to go in. Um, you know, once like the football life and all that kind of ended, I had to figure that out on the fly. But I think, you know, whatever your interests are career wise, start looking at what careers are out there, salaries of those careers. I think that's important. You know, can you live with certain type of salary or income? And then ask the questions, reach out to people that are in those careers, try to do some kind of shadowing. I mean, you know, we do an internship here at the refinery that we basically started putting together years back for machinists and now welders and other careers. And those type of opportunities, if you can do them during the summer, you know, your breaks, after school activities, any of that, it'll just give you an idea of if it's something you really want to do before you go out and spend, you know, tens, if not hundreds of thousands of dollars on a education that, hey, I don't really like doing this, and now I still got to pay for it. In my personal opinion, I think that that's great because I see a lot of students, you know, even at the college level that I work with, that they get into something, you know, they get vested into it, and then they realize, hey, I don't really want to do this. I want to do something else. It's kind of hard decision to make at a young age, but it's nice to kind of get your head around the options that are out there and what the world has to offer you.
Thank you. That would save you time and money for sure if you do that early on. All right, Johanna.
Can you restate the question? I'm sorry.
Oh, no problem. What should students do now in high school to better prepare them for college and or career? Any tips and tricks that you can share?
One thing that I did that I think really set up, you know, ultimately led to the decision that I made for polymer chemistry was I got an internship at the local university doing research. And while, people aren't always hiring high school students, I think trying to make those connections with, universities and programs outside of your school and having that drive, people notice it. So even if it doesn't lead to something right off the bat, it may lead to something downstream. So just if you're interested in it, just send out an email to somebody, just ask and see what happens. I think that really helped in figuring out my path.
Thank you. This is the second time we heard the word internship. So students, internship is one of the keys. And our engineering pathway here at Ignacio Valley High School has a advisory board of professionals, and we always talk about bringing internship to our students in the engineering pathway. So that is something that's one of the biggest benefit that you get if you stay with our program. All right, let's continue on with Ken.
So a couple things, definitely same thing as mentioned by everyone previously. Anything you're interested in, do some research, look and see what's available, reach out to those places, businesses, and companies. Take advantage of your teachers and also any student counselors you have at school because they have contacts in some of the places that you're interested in. Look for internships, job shadowing, all those things. But also look at volunteering because volunteering is a good way to get exposure to some of these industries and also make connections with other industry partners. Like they support and help a lot of community and school and different types of volunteering to make those connections, get exposure. And then the last one was really about school itself. Like not everyone, I kind of took a longer path to complete my college education. So I took, I spent some time at a junior college as well, Laney here in the Bay Area and whatnot. So junior college is also in Sacramento State, actually, both of those. Junior college can be a great way to save on costs, get some of those general education classes that everyone has to take out of the way, and then also help you focus in on what you really want to do before you spend the big bucks of going to sometimes a 4-year college or whatnot. So those are a couple of the things or tips that I would say or recommend.
Thank you. There you go, guys. So one biggest takeaway for me, I don't know what you got, but junior college. So start looking at, especially our upperclassmen, start looking at DVC, LMC, the colleges that are close to us. Okay, and save some money before you move into that 4 year. Okay. Last for this question, how about Noah?
Yeah. Could you restate the question?
So, what should students do now in high school to better prepare them for college and career? Any tips and tricks you can share?
Yeah, I mean, I agree with what everyone else has said. I think one of the biggest things for me, at least, is that kind of reflecting on what I wanted to do with my skills and what I was good at and what I could kind of like foresee myself doing. Just because I liked electrical engineering doesn't mean that I had to be an electrical engineer or I liked electricity. There's a lot of overlap in careers. I've realized later on that, you could be, a chemical engineer and do something that an industrial engineer does, or be an industrial engineer and do something that a mechanical engineer does. But you might have a skill that you really wanted to develop, problem solving or memorization just in general, but just reflecting on what you enjoy doing from day to day and really nailing that down, something you can see yourself doing every single day. It's something, that should be, I would say that should be done in high school before you make it to college. That way you can really understand like, oh, I like this. I'm going to apply this to, my to trying to become an electrical engineer or a chemical engineer or so on and so forth. But really understanding like where your skills can fit in industry.
Thank you, Noah. So once more, discover what skills you are interested in, and classes like this is here to help you out, figure what skills you are good at, and of course, all your other classes in high school also. Okay, so let's move on to some technical questions for our guests. Okay, and this question is again posed to everyone. Our most recent lesson in this class is about simple machines. So specifically, we talked about pulleys and levers, and I asked the kids to record a video of them creating levers and pulleys out of everyday material that they could find at home. As a professional, so my question for you, and they found out that using those simple machines made work easier. Okay, so let's talk about what makes your work easier for you. It doesn't have to be a simple machine, of course. So the question is, what machine, tool, equipment, or software or app do you use in your line of work often that you cannot live without? So once more, what machine, tool, equipment, software, or app do you use in your line of work often that you cannot live without? Let's start with Johanna.
So my work is in additive manufacturing, which is 3D printing. So I can't do any of my science without having the printers available. And so the printer itself, what type of printing system I use changes as my research develops. But the act of 3D printing is kind of fundamental to my research. Making these materials for these processes, printing them and seeing, if they go awful or if my materials look cool. It's been pretty fun, but without the printer, I think I would have to do some other type of science,
Awesome, thank you. It's unfortunate that some our kids, especially the freshmen, aren't in class right now because that's one of the things that we're supposed to be using. So hopefully by next year, they will get to use a 3D printer in class with me. But I guess let me ask you, is it possible for us to email you and ask for a picture of you with your 3D printer and some of the things that you've 3D printed?
Oh, absolutely. Yeah, definitely.
Okay, awesome. Thank you. All right. How about you, Joshua?
I would say CAD. If I were to say one tool or program, CAD is definitely a staple in the industry. I think across the board. I think everybody here has probably had some experience with it or has dealt with it in some way. And it can be across many industries. Like I said, the piping side. So here at the refinery, CAD is used for a number of things, but a lot of the now machining technology is all CAD driven. So if you can learn to program through CAD or design and draw through CAD, it opens up an entire workforce opportunity for you as far as piping design goes. Architects use CAD for home plans, industrial plans. Like I said, the machining side of it now, it's all CAD driven. It's not as many hand tools anymore. It's all computerized. So I would say CAD, which is computer animated drafting, is probably the staple of the industry.
Okay, thank you. Our kids had experience with Tinkercad, and some other students in this class started using Fusion 360 and Onshape. Which CAD system do you use in your line of work, Joshua?
Several. So I have to pull up the exact names of the different programs for you. I can get you guys a list and pictures of some of the work that we've done through it. But we use different ones for piping. We have a laser cutter here for metal. So we'll do, like plasma art cutting, any kind of shape design with that. And we just put a new CAD driven mill in the shop. So that's going to be a whole nother CAD program. So I know there's several out there. I can figure out all the ones that we use here on site, but there's a number of them that we use to basically do all the manufacturing that we need to do here.
Awesome, thank you. That list or pictures would be greatly appreciated. Thanks. Ken?
Sure, there's a whole host. Being frankly honest, probably the most right now would be Office 365 and Teams, which is all the communication, Outlook, email, Notepad, multiple programs under that umbrella. But as a company, and that's one foundational for the company, but another one, kind of like with CAD for us, we use that too, but GIS, so geographical information systems. So all of our assets, all the pipes and wires and stuff being geographically and virtually represented, and being able to play with, manipulate that, and put it on multiple types of devices, whether they're desktop, mobile phones, tablets, and iPads, for people to do work in the field or do design in the field or in the back office. So those are a couple of those key programs that we have and use like every day.
Awesome, thank you. So kids, you heard Office 365. Of course, we don't use that. We use Google Suite, and that's the equivalent of Office that we use here in school. Okay, thank you for sharing, Ken. And the last one is Noah.
Yeah, so I use a lot of like really expensive pieces of equipment every day almost, but it's really all so that I can take data. So the main tool that I use is a computer, and that's to acquire data automatically, to analyze it automatically. So I use a lot of LabVIEW, kind of like MATLAB. It's a really simple programming environment, so that I can automate a lot of tools. And one of the things that I've found that really helped me in my research was being able to automate. It's a probe table. It's just it's almost like a 3D printing head, but the table actually moves back and forth. And then you have two probes that come down. The table can move over and then up, so you can automatically test devices that are maybe 100 by 100 micrometers wide, and just move from one to another. So instead of having to do it manually, which might take, days to do it manually, it can take 2 or 3 hours, and you can go have lunch during the whole time, or do other work. But yeah, a computer is like the biggest thing that I use like day to day, just so I don't have to, waste my time doing Excel sheets that are like a gigabyte large.
I see. At this point, kids, we are stuck with Google Sheets or Excel, because I know those kinds of software, they're a bit costly. Is that right? Those types of software that you use?
Yeah, some of the software is a little bit costly, not to students particularly, but if you were interested in learning the program, I believe Python is free. It's very similar to MATLAB, which is also a little bit cheaper for students. MATLAB is, but Python I believe is free, and it lets you do a lot of the same things, but without some of the libraries that are included.
Okay, thank you. Thank you. All right, so our next question. So I got this from Nathan Islam and Sarah Richnabsky, student in first period and fourth period. Can I have two professionals please answer this question? What is the hardest or most challenging project you have been involved in? What is the hardest or most challenging project you have been involved in? Anyone?
I'll start. So here at the refinery, we do what we call a turnaround or an outage, which basically means we'll take a portion of the refinery out of production and we'll isolate it and we'll do like a major overhaul work. We'll open the whole unit up, right? Replacing valves, going inside vessels, repairing turbines and other rotating equipment, et cetera, et cetera. Long, huge list at times, depending on how large of a section. Well, we just actually through Thanksgiving week wrapped up an emergency outage where we had to shut down the cat cracker unit, which is like the heart of the refinery. It's basically where we use a very large turbine to push all the product through the entire refinery. And it came down abruptly, and it was kind of like an all hands on deck to plan and execute this huge, large scale outage with minimal personnel because of COVID, right? So there was a lot of challenges with that. We pretty much ran it with the small maintenance team. The turnaround group was all at home because of COVID. So doing a large scale, which typically would be probably a 1 month around the clock, 24-hour a day outage, we did in 14 days around the clock with only personnel that we had on site. So that was kind of a big challenge. This industry, we see that kind of happen often where, as Mike Tyson would say, everybody's got a plan until you get punched in the face. It's kind of that way at times in the refinery. It's a 24-hour, 7-day a week, 365 business. And when something goes wrong unexpectedly, it's kind of whatever we have to do to fix it and get it back up and running. So that's, particular to my industry, is something that we face some years more than others, but every so often we get thrown a curveball and we have to kind of, all hands on deck to make it happen. That could be challenging. There's a lot of thought that goes into it, a lot of personnel that goes into it, hours, materials, planning. There's a big cost portion of that you want to do it with minimal costs and minimal downtime, and of course safety, right? You want to make sure you keep everybody that's involved safe. And so we just did that, what I would believe is a successful turnaround, but it was a challenge.
Thank you, Joshua, for sharing. And Johanna, I have a question specific for you here. So it's related to the question that I just asked. So what is the hardest or most challenging project you have been involved in? So Louis wanted to ask, what example of a research have you done in additive manufacturing? Because this student is into 3D printing a lot.
Oh, very cool. Well, that was going to be my answer anyway, so this works out. One of my projects from grad school, I and my professor invented a new type of additive manufacturing called multi-material actinic spatial control digital light processing additive manufacturing, big mask printing. And the way mask printing works relies on fundamental chemistries. We have a mixed vat of photoresin, where when light goes in, it polymerizes a layer of material into a solid sheet. And you can use a projector then to create every layer at the same time, right? Where you build up layer by layer. That's a digital light processing, additive manufacturing, 3D printing. Multi-material method, I have a mixed vat of resin that has two different polymers in it, or two different monomers. And so when we shine different colors of light, we can have different materials polymerize. So wavelength 1, you get like a hard material. Wavelength 2, you get a soft material. You shine a multicolor image into the vat, you get a hard and soft object. And so that was a project that took about 4 years to get the funding, get everything aligned. I had to learn optics. I'm a chemist, right? So learning optics and aligning 2 different projectors with different wavelengths of light into the same vat was hard. And then getting the chemistries themselves to work so that we got truly, we call it orthogonal, truly separate polymerization. So that was a whole process. But that got published in my 5th year. So mask printing is now a multi-material method that you can use. And so I actually try and use that now in my work here at Lawrence Livermore National Lab.
Wow, thanks for sharing. And this makes us think much more about 3D printing and CAD. Now we have to think about the chemistry of the filaments that we also use for 3D printing and all. So, wow, that's a new perspective even for me. Thank you for sharing, Johanna.
Absolutely.
All right, for our next 2 guests, let's switch to a different question. This question is from Albert Salazar from my 4th period class. So this is something that you haven't done yet, okay? So if you have the opportunity to make, create, build, start something to make the world better, what would it be? So if you have the opportunity to make, create, build, start something to make the world better, what would it be? And so this question is for Ken and I think it was Noah, right? Ken and Noah.
Sure, I'll maybe go first. That's a great question. There's so many things out there that could be, great and improve the world that we live in. I think one thing that would be zero energy consumption transportation. So, something, whether it be a material or that could provide enough energy to, transport or do transportation from place to place or globally or whatever, that didn't cause any carbon emissions, use or burn, fuels and all that kind of thing. So it would be, essentially net energy consumption zero, which is kind of a super interesting problem to solve. But that would be great because, then a lot of the environmental and global, warming issues and things that we face, which are transportation, building, and some of the basic industrial types of ways that industrialized countries work, would, essentially be halted, improving holistically the planet and people's, life today and in the future overall. So that's my kind of long-winded answer to that question.
Awesome, thank you. So just think about that, guys. So energy, trying to solve an energy problem will, in a way, improve our environment issues also. So thank you for sharing that. And Noah?
So I work in, the research I do is in energy efficiency. So I'd love to be able to have my research work and actually be able to help make cars a little bit more efficient, electric cars that is, a little bit more efficient. The thing that it's a little selfish, but the thing I really want to build is a research lab. I love the idea of being able to give back to students, because I think that, the biggest impact that I could make is actually, training or helping train students in order to, fix problems in the world. So being able to actually create a lab or create a career or, continue my career in creating a lab and giving back that way. So, yeah.
And I do really hope that your dream materializes soon, because I know a lot of students out there would want to benefit from a lab like that. Thank you. So we're nearing the end of the hour. So let's ask a closing question, one closing question for all of our professionals today. And the question is, what is one practical piece of advice you would give a student thinking of becoming a STEM professional? Once more, what is one practical piece of advice you would give a student thinking of becoming a STEM professional?
I'll start on it. If it comes to my mind, I would say STEM or any professional is the soft skills. I think we don't talk about it enough in school. I know, and just something I know that's becoming a bigger focus in school. I think at the high school and the college level is the soft skills, and what I mean by that is, uh, having the personal skills to sit in an interview professionally and be able to interact with other people. I've seen it all spectrums of types of professionals, and some people are more people person than others. Some get very buried in their work and are kind of antisocial. But I think it's important to learn and to practice those skills as far as when you go to sit in an interview, whether it be with an internship, doing mock interviews with your teacher, other students. It's very important, certain key aspects, making eye contact, having, asking questions if you have them, um, having the question repeated if need be to give clear answers, trying to work on being nervous and other things that could affect the interview process. I think it's important. I've done a lot of interviewing myself, and I see a lot of different people that struggle with that because they haven't spent any time working on those skills. And it's important. It's very important as you get into a professional career, or even certain schools will make you do interviews. So it's something that it is important to do.
Thank you very much, Joshua. And for my CCAP STEM kids out there in the audience, so you had your first interview with professionals. See, so that's what Joshua just pointed out again for you guys. So thank you again, Joshua. Anyone?
Yeah, anytime.
I can add to that. My one suggestion is grad school is really fun, at least in my opinion, but it's only really fun if you choose wisely. So picking a place you want to live for, it's 5 years, college too, 4 years, right? Picking an environment that you enjoy, picking an advisor or person as a support system that you enjoy, picking research that's interesting to you. Those are all things that will make it so that, grad school flies by instead of trudges along. Um, Same thing for college. Just enjoy it and pick places that you know you will enjoy, and also that don't break your bank for obvious reasons, but yeah, just have a good time.
Thank you. Have a good time. All right. You should have fun with your choice. All right. Next, Ken.
Sure. I agree with what's already been said. Two quick things. I would say stay curious and always learning. That's going to drive you and help you stay motivated um, and learn a lot of things that you may not think apply in the moment, but will serve you well, through your life and through your career. So always stay curious and, educating, always continue to learn. And then, make sure you seek out help. None of us have gotten to where we are without some support or some help along the way, whether it was direct or indirect. Seek out those mentors, sponsors, advocates, supporters, because they're the ones who are going to give you advice, open doors, some that you may not even realize, um, and help you make connections and understand things that you may not be understand or have a sense for right now. So always, stay curious and always seek out support and help, and be willing to support and help others as well.
Thank you, Ken. So one more time. So seek out support, stay curious, and thank you, Ken, Johanna, Joshua, and Noah for supporting our kids today. Then finally, let's have Noah.
Yeah, I agree with what everybody said. I would definitely recommend to take time to be bad at something. If you're interested in it, I mean, the most I've learned from about any subject is when I was really bad at it, and just all of that practice in order to like learn how to program, or not knowing something about my research, is taking that time to really not understand and like get myself better and better and better at it. Is okay to not be good like right when you start out. You don't have to be talented in everything or anything that you're like interested in, but as long as you take time to be bad at it, that's a skill that I think is necessary for, I think, most of STEM, like being able to stick with it and be bad at it until you're good at it.
Awesome. What a great way to end our session. I always tell my kids, fail fast, fail often, and then eventually you'll figure it out. So be bad at something until you get good at it. So thank you very much again. So kids, let's show some love to our guests. You could unmute yourself, say your thank yous, or go clap.
Thank you.
Thank you very much.
Thank you.
And you could type also in the chat because our guests could read it. Here they come from David, Christian, Sarah.
There they go. There we go.
All right. And then I do that because these kids, especially the freshmen, are going to be with me for the next 3 years. And I do hope that this is a start of a great relationship between you and them, and that we hope to have you all back again, just like Ken, okay, back again to one of our sessions. As a matter of fact, Johanna, we have the Girls Only Career Mentoring. I don't know if you've been part of that already, but we do have that. And so April will connect with you. Hopefully we could get you there. We have 17 women in STEM who come and mentor our girls as well.
Very cool.
All right. Thank you. And for the students, if you go to our assignment for today, I already posted the link for the career panel reflection. So everyone, can you please go to Google Classroom and go do that, please.